fast do you think we can go? I think you can accelerate hard all the way to the scene of the crash. I have a suspicion that we'll put them under the shaft and they'll just pendulum swing.
You'll see pretty much right away.
I'm shocked. And the fact that some of these are coming out like this is to see something like this. I'm flabbergasted. I really thought that we were.
Isn't that better than like car tires?
How's that?
Fun.
Brought everything but the tool we need.
We've gotten 30 mile an hour of these tires so far, but that was on a backhoe. And if we want to go higher speeds, like 40, 50, 60, who knows, maybe 70 mile an hour, I kind of got a feeling that balance is going to be important. So we thought, hey, let's take out 4 of our tires, go to a tire shop, get them balanced, and just see what happens. And I have no idea how this is going to go. We've never tried it before. It could be an epic disaster.
The challenge with driving a tire that is not balanced is vibration at higher speeds as the vehicle is traveling. This can lead to shake in the front end components that transfer into the vehicle and up into the steering wheel. The team wants to see if they can properly balance the tires to prevent this from happening during tire testing, so the tires are safer to run at higher speeds, up to 50 miles per hour.
You don't have to be gentle, you won't cut the tire.
Well, if they can't handle a little knife strike, they're probably not going to stand up in the world.
We've actually shot them. We've tried blowing them up. We've had fun.
I'm curious to see what's going to happen when you get them onto the balancer. I have a suspicion that we'll put them under the shaft and they'll just pendulum swing.
You'll see pretty much right away. These ones, I think they did them center offset.
Yeah, they're centered.
Yeah.
Yeah, dead center offset.
Yeah, those are right in the middle.
Hopefully we don't break your machine.
Shaft for 550 pounds. Hey, perfect. Probably going to mark them a little bit because it's a steel on steel.
That's fine.
Yeah,
Okay.
mark away.
That's okay.
We're gonna scratch them too. He's gonna put it on and he's gonna be balancing it. So this goes onto the shaft. That machine, you'll just push it over. See, nice line. And it'll go back down, throw the plate on. And they're gonna line it up with the center bore and cap it like this. And then the rim will be in the middle. And then that's what will keep it centered.
That's a lot easier than what I thought we were going to have to do and lift it on.
The team has scheduled dyno testing for their airless tire designs, but before they run any tests, they've decided to balance the tires to prevent issues during rotation. To balance the tires, each one is mounted on a balancing machine and spun. The machine measures how much weight is needed for proper balance and identifies exactly where those weights should be placed on the rim. The weights are then added, ensuring the tire is properly balanced.
No, we've never balanced one of our tires before because they're only made for like, 12, 15 mile an hour usually. And we've ran this one at 30 mile an hour unbalanced and it was fine, but we've never tried to balance it for faster than, 12 mile an hour, because on a skid steer you don't have to, but on a truck of any kind, you're gonna have to, if you're gonna go 40, 50 mile an hour, then you're gonna need a balanced tire. So this is a new first for me. Since we started, I've never done this.
Let's see what we got here with this one. There we go, 14 out.
Wow, you called that close.
Go get me stick-on weights, please.
14 ounces? I take that. 14 ounces for something we've never done before ain't bad.
No, this is just a tiny, tiny bit. And
Yeah.
the tire itself, for speed, yeah, we can balance it. I can put weight on the tire, and this machine will tell it. Yeah, if it's not running true,
Yeah.
it's bad. These were the weights I was saying. Like, so if you guys are going to start balancing the steel rim beforehand, these can be supplied by any tire man. These ones just stick on, but if you're gonna pre-balance your steel assembly
Yeah.
beforehand. Just like I said, with a bubble balancer style, you can take this, peel this backing off, and then they can be welded right on because these are steel.
Oh, okay.
So, and you can get them in 1/2 and 1 ounce weights, a quarter, 1/2 and 1 ounce. So you can get really pretty fine with your
Pretty fine.
balancing. But we're gonna take these, I'll stick these ones on.
That if it's not perfectly round and like, because I was watching, it was maybe like 1/8 of an inch kind of thing.
Yeah.
But like that's going to get soaked up if we have over 1/8 of an inch of compression on the tire. It'll get soaked up in there too, right?
True. Yeah.
So you've got, so that was just balancing for up and down. So you can also dynamic balance. So that little bit of side to side motion that you guys seen,
Yeah.
it wants 24 ounces to side to side. So when you're on road front tires, that's gonna cause a little bit of.
Yep.
But we're just gonna weight it on the one plane for today because you guys are putting it on a dyno or something. I was certain.
Yeah. Let's see how close we can get it.
Okay.
So we're going to try and balance it, you know, for shimmy and also like vertically up and down. I'm hoping to get it perfect, but you know, like I've got 40-inch tires on a off-road truck that I think we put on like 13 or 14 ounces of weight. So, you know, we're close. Closer than I thought we were going to be honest with you.
Well, it's like when they do the drive shaft balancing, they just tack the weights on, right? Yeah.
So what it does is it adds weight so that the
Yeah.
tire will stay true.
Essentially what it's doing is it's spinning a shaft and it's measuring how much that tire is pulling on the shaft in each direction. So if the tire's pulling, and it'll calculate based on where it's reading from. So if it's pulling, you know, as the tire in a certain position going, then you want to add to the opposite side of the tire's pulling. It's pretty straightforward, but there's a little bit more to it than that. But that's kind of the basics of it.
You're not going to be taking this truck up to 70 mile an hour.
No, be 50 is where we're trying to push.
Yeah. And then hopefully you got brakes to
Bring you back down.
bring it back down to a grinding halt.
So should we try and do like the standard balance first and then see where we're at?
You don't need the dynamic balance.
Okay.
What you want to do is you want to make sure that this thing isn't hopping when you throw it on a dyno. It's not hopping when you're trying to roll it down the road at 50 miles an hour. A static balance would mean that if it was balanced on a plane, it would roll straight in that one direction. But if it was out of balance dynamically, any other direction you rolled it, it would slowly start to turn, right?
Yeah. So then,
I'm thinking that you,
Just throw the 14 ounces on and
Yeah,
and go from there.
let's do that.
yeah.
see the robot and head fixtures will make that wobble go away.
Absolutely. Oh yeah.
So where did we go from? We were at 14 and
We ended up right at 14 to balance it out.
now it's balanced?
And now it is balanced for hop. We'll run that and then go from there.
Like these were done with by hand. We normally do them on a robot.
Yep.
So like there's gonna be a little bit of variability there too. But
Yep.
like once we get to the robot stage, we can get it pretty consistent. Like if we need weld here, we need weld there, right?
See, once I get to the robot, I can do the weight. The robot will actually tell me where I'm out of weight.
Oh, will it?
Yeah. Oh, cool. It tells you exactly where your object is that you call a tool, and when I rotate it will tell me where the tool moves. Learns. It's just going to say, hey, at J270, I had a wobble out, right? Right now I have it turned off because we're welding as we're going. So then it would always be screaming, I'm out, I'm out, I'm out, I'm out, until I'm done weld, right?
How fast do you think we can go?
I think you can accelerate hard all the way to the scene of the crash.
Yeah.
Oh, this one's falling. Oh, he's already starting. Yeah, see, this one's got the hop, eh?
Oh, yeah.
8 ounces. All right, because
Can you run that one more time? I just want to see.
Because you can see it in the rim from here.
In the tread, there's not too bad though. But I mean, again, if you go with an aluminum rim, you can get right there.
Oh yeah, you can knock every part of that out.
Because I mean, we're starting with steel, but there's potential to go to aluminum next, right?
Yeah.
Because then we would also drop out probably 100 pounds of weight.
You got to remember, just even though it is a cast that you start with, like a solid block, it will have heavier sections.
Yeah, totally. You're still gonna have to balance it, but
Yeah.
you'll be
It's
able
gonna
to
be
be a little bit
not-
more accurate.
yeah.
If you're looking at off-road applications with heavier braking systems, then we're not that far out. Everybody says that solid tires can't go at high speed, right? Because of heat buildup.
Yep.
We were at 30 mile an hour and we don't have any heat buildup issues at all. Like we went 60 miles, one run, and never had a heat buildup issue. We were running 20 degrees Fahrenheit over ambient temperature. We were only like 120 degrees Fahrenheit. So like we're way under the limit, right? So our thought process is, okay, we can go 30 mile an hour. Can we go faster, right? Like, can we get to 40? Can we get to 50? I was on a backhoe. Yeah. Because if we can go to higher speed applications without having a heat issue, then okay, that opens some doors, right?
Yep.
And we don't know what doors those are until we know how fast we can go.
Exactly.
Like you think about it and everybody says, oh, well, you're gonna have a problem stopping. Well, I appreciate that, but nobody's ever had a solid tire that can go 40, 50 mile an hour.
Yeah.
If you had an option that could go 40 or 50 mile an hour, then an engineer can design a solution around it, right?
Yep.
That's how innovation starts, right?
Exactly. Yeah, you got to start at one spot and work to the finish.
I didn't think we were gonna get them to balance at all, never mind be within 8 ounces.
Yeah, I'm actually, I'm quite shocked that like 8 ounces, that is the absolute extreme for some of our big truck tire.
But how fast do you spin that up to?
It simulates 60 miles an hour. Is what it's supposed to do. I know it's not spinning it at 60 miles an hour, but that's what it.
Well, the outside of the rim likely is getting close to 60.
So is that balanced? Is that what it says?
It's 0. Perfect.
To the top.
Maybe we're a little better than we get credit for.
Hey, you know what? This castings are exceptionally uniformed.
Well, it's injection molding, right? So like, if you look at how most tires are made, a lot of tires are made with compression molding, which bring us, well, I actually don't know any other solid tire that's made with injection molding.
I don't.
And so they're all made with compression molding, which just adds a whole bunch of variability into the system, because if you have air pockets in the rubber or whatever the case is, because of how that rubber comes together, then you're gonna have balancing issues from that, right?
Yep.
And then you also have like more rubber in some places or less, depending on how the mold closed or whatever the case is. Whereas with this, the mold's tight, it gets injected as like a kind of like a semi-solid liquid form, and then it fills the cavity like perfect every time under pressure, right? It gives us a couple of things that you don't realize. A, it gets you a really consistent part every single time for weight, but it also gets you a really consistent part for wear life, because it's 100% uniform rubber.
Yeah.
Whereas a solid tire is just like a typical solid tire that is compression molded, has void space, has inconsistent cure issues, all these other things, because it wasn't like it. For us, it gets forced in under 25,000 psi of like, liquid form, so it has to go together. It can't go any other way. Whereas like when you put in, slabs of rubber into a mold, there's just inconsistencies, right? Because the outside gets more heat than the inside, and all that kind of stuff. So I'm not quite surprised. I'm not surprised about the weight being the same. It's more the balance, because hand welded rim and everything else, right?
Compression molding heats the material and presses it into shape. but it can flow unevenly and create small inconsistencies. Injection molding forces the material into the mold under controlled pressure, filling every cavity the same way. The result? Tighter uniformity and more consistent performance.
So what's the over-under on blowing drive shafts before damaging the tire?
I actually don't think we're going to blow it at all because we're putting on a 69 Chevy C30 with an Eaton Fuller axle. So that truck wasn't made for going, 70 mile an hour to start with. It was only made to go 50. And if that fails, then we're going to put it onto a 5-ton box truck. And honestly, the run out on this one's better than the other ones.
I'm gonna say this side's worse.
Yeah, well,
That side looks better.
this side straight up and down looks
I'm gonna
better.
go with 9, 10. Going 10.
0, it's perfect.
There's no way. Seriously? Did it go to 0?
Evolution Wheel, we make perfectly balanced tires. Two?
Couple of ounces, yeah.
Hey, isn't that better than like car tires? It's funny that you say like it could be one segment because I only see the one spot going bip, bip, bip.
How I assembled it, right?
Wait a minute, 2 ounces? Like, holy shit, did that just happen?
I'm shocked. I even at the 14 ounces, I was shocked that it was that little of a weight. And the fact that some of these are coming out like this is, it shows that whatever your manufacturing process is at least, if nothing else, very uniformed, which is a good start of a product, right? If you can make something the same all the way, you can work out all of your other issues, right? So you've got different compounds that you're working on, you've got different wheels you're working on, but if your base product is uniform, I think you guys are going to be able to do a really good job if your prototype is this uniform, that if you can take that back into manufacturing and keep it close, it's quite impressive to have seen it to see something like this. I'm flabbergasted. I really thought that we were, like you see, they went and got me 3 boxes of weight at like 10 pounds a box. Like,
Yeah.
I was expecting that I was going to be using a lot of weight.
I saw him coming in with the weights and I was like, oh yeah, they're really confident we're going to be able to make this work.
And the fact that it is this uniformed and you can see that right now, you can see that the major run out issue is the steel hub that you're building against. And if you guys figure something out for that, I think you guys are light years ahead of where you probably think you are, I think.
We put that same build quality into every single one of our tires. Like, we made this no different than how we make a skid steer tire or a telehandler tire. But like, you don't realize that until you go and do something like this, right?
And,
but like, we're not made in China, we're made here with people who are caring, right? When I can walk down from my office or out into the shop from my office and look at a guy welding, he's gonna make sure it's right versus buying something from on the other side of the world, right?
Yeah, you guys aren't just sending blueprints off somewhere, here, manufacture this for me, and it comes back to you. Quite impressive that everything is. Zero, yeah.
Huh?
How are we gonna machine it?
That's easy. Drop her in the mill and go. Yeah, so we had 12 ounces, 8 ounces. 14, 8, and 2. And we expected to not balance anything, so. Mount these on a race car, let's go. like I said before, you're not gonna put these on something that wasn't designed for it, right? But if we can make a tire that balances and has heat resistance and has other attributes that are useful, well then, okay, maybe there's applications that need it and couldn't get it before, right? So sometimes that's why you do things. You don't know what the end result is, but like, I own the company and I didn't think that there was gonna be like that. So I'm pretty sure that coming here, everybody thought this was gonna be a joke, right? And it's always a joke until you prove that you can do it. We're balancing similar to like an off-road air pneumatic tire right now. I mean, the last one was exceptional, but like, you know, if we can hit, the first one was 14 ounces or whatever. So like, I've got 37, 12 and a half 18s that are same thing, right? We put in 12 or 14 ounces. 6. Pretty good. I think you're going to be able to keep your 10 pounds of weight and use it for somebody else.
Yeah, no, like I said, I was expecting when I seen the 14, I figured that was probably going to be the better or at least the average. I did not think that we would be anywhere like this.
Well, I'm interested to see how tomorrow goes, because every step of this project that we go, we always are seeing better results than what we thought. So I'm pretty interested to see what this does on a machine, on a dyno, like on a truck and on a dyno.
It's rare to see people who don't fall to hubris. They think they're better than they are. They come in and they're like, this is going to be the best thing ever. And you guys seem to have come in here with a reasonable expectation and hoping you're going to meet it, not...
The difference is that we've R&D'd every single project, every tire we made, we R&D from scratch, right? So like, I had that issue when I first started, and then when you're well into the 6 figures deep into an R&D project on a tire that you thought should have been like done like that, you get humbled really fast. So starting a project like this where we're trying to make a tire to go high speed, and nobody in the world has been able to do it, I didn't come in with high expectations. No, I mean, next steps is to run it on a truck and see what it does, and then, you know, see how fast we can go before we have heat issues. Because like, we went 30 mile an hour with no issues, but can we get to 4? Like, where's that start? Does it start at 40? Does it start at 50? Does it start at 60? So until we test it and try it, we have no idea. And then from there, it's like, okay, let's say we can go 40 or we can go 45, right? Then is that fast enough, or do we want to go 50? You know, and then from there, it's like, okay, to hit that, I think where we're going to get to is a point where it's like, we're at 45, but we want to go 50. So what is it that last 5 mile an hour needed? Is it a rim that is perfectly balanced so that we can get a better balance here, both like statically and dynamically? Or is it like
Yeah.
What is it, right? We don't know.
Find that point of diminishing returns, right?
Yeah.
That,
The devil will be in the details to get from where we are, wherever that is, to where we want to go. So it's always devil's in the details.
Yeah, I can just grab a drill and try and for it though. I'm not. 0. Look at that, perfect.
Very nice.
6 ounces. Okay.
all I could see is that if you guys figure out that concentric wheel to bolt to, everything else is awesome. Like, it seems like your rubber is as far as I could see, is that manufacturing process you guys have gotten quite good at. So it's very uniformed in the rubber. So
nope.
you know, that last 5% is that wheel, and then you know, the last 5 is always the hardest 5, but
it's the most expensive one. All right.
I bet you we barely hit over a pound and a half. 14, 8, 6, and 2.
Bravo, gentlemen.
Bravo. I am thoroughly shocked at how little weight all of this took, being solid chunks of rubber.
Next time we're here, I'm going to aim for 1.
This is a different conversation than we had.
Yeah, like I said, we made a joke already. I said, you notice that he went and got me 3 boxes of weight, and yeah,
So what did you think when, like, coming in here? Like, you can give me your honest opinion, I don't care. Maybe you thought I was going to be terrible, but like, what did you expect?
We had significant anticipation of fully using 3 boxes of lead,
Have you ever tried it before, or have you ever, like, with a solid, or?
Balance a solid? No.
Yeah.
No, because, well, this is going to be that 0.01% of solid tires that's going to end up going over forklift speeds or going over
Yeah.
bobcat speeds,
Yeah.
right?
I was just curious if anybody ever
That's
done
where
it.
the tires. So, you know, somebody planning to take a solid up to 50 miles an hour, I think it's I don't know if I want to ride in or be able to stand beside and watch it all happen.
Well, it's like we were saying, like, when you had walked away, like, we don't know what the application could be yet, but nobody's designing a truck or anything else to go that speed because nobody can do it, right? Like, they all say, like, well, we can't go that fast. But if you can go that fast and, like, an engineer knows that, then you can design around it, right? But if everybody says, oh, it doesn't happen with solids, then of course you're not going to put heavier brakes on it, right?
So could the wheel assembly be made out of aluminum?
Yeah, and that's kind of like these are 100% prototypes, so like we're just talking about machining it out of aluminum to reduce weight, and that would probably reduce us like at least, what, 50 pounds, maybe 100?
Yeah, probably.
So like if we can drop from 300 to 200, you know, or 220, because the rubber weight itself is only 130 pounds, 135. Well, cool, guys. I won't take up any more time, but that's...
We're gonna check out those stats quick.
Yeah. Anytime something goes better than I expected, I'm always overly optimistic at this point, but I really expected that to go a lot worse than it did. I was always confident in our manufacturing process, you know, being very consistent and repeatable, but like, I've never balanced a tire before, so to be able to hit those numbers, I'm pretty shocked. And all of a sudden I'm a lot more optimistic about the success in this project. But like, so far everything's been going pretty well, and yeah, I'm a little shocked. I think we definitely might have something.
They seem pretty shocked in there.
Yeah, when the guys who have balanced, you know, thousands and thousands of tires are pretty shocked, then, and we can turn some opinions of those guys, then that's saying something.
I'm astonished. Literally, you can record that as many times as you want. And that I've learned a lot where I can put it into manufacturing.
Yeah, I think that's a big takeaway too.
Like-
is the manufacturing tolerances that we can control that will
On all.
make it even better.
Because now I can apply those concepts to all tires to make them that much better. Like we always are. Learning, getting better, being better every day.
I'm a little excited, but I'm not trying to be too excited because I'm waiting on the smack in the face that we're gonna find at some point that we always find on these projects. But so far everything keeps like ticking along and going well, which makes me a little uncomfortable, to be honest with you, because there's nothing that we're like, we have to engineer this. I mean, this project's the culmination of like
All our product lines.
20 tires that we've R&D'd, so like a little bit we have some benefit obviously of experience, but at the same time it's like there's always something that smacks us in the mouth that doesn't feel good and we have to figure it out. So like, I'm just waiting to find what that is.
But then it just gives us one more thing to learn and overcome. So I find it was a benefit. Well, I'm gonna go grab 100 segments and I'm gonna weigh them out this afternoon, I can tell you. I wanna see how accurate we are every shot. Because then if that eliminates that, then I actually can know how to make the rim more balanced. I'm astonished that it's not where the weld is. It didn't care about the 3-4 ounces of weld that we put on the inside of the seam.
Because normally we grind that flat, but on these ones we didn't.
Yeah, for extra strength. It's nice to have people that will give you knowledge though. Like that guy stood there for what, 2 hours? Just
Absolutely.
I definitely think when we showed up that it was kind of a joke in their mind.
Yeah. Oh yeah.
not a joke leaving them.
We've got 4 balanced tires, which nobody thought was going to happen at the end of today. I think at this point, we need to get these tires onto a dyno while we're still waiting for the Humvee to show up. I've got an old C30 project truck that I think will handle it because it's got an Eaton fuller rear end. And yeah, I think we just go smoke them and see what we can do. If you like what you're seeing in this video, hit the subscribe button, the like button, do all those good things, keep following along. We got more to come, and let me tell you right now, you're gonna be entertained.